I tried to invite everyone to OneNote. There were 2 people who it wouldn't let me invite. That means they haven't used OneNote using their Union College account or something like that. One of them was Michaela. I don't remember the other one. But if you don't have access to OneNote, the class, it's probably good to get it because that's where you can see all of the lecture stuff I do. And so yeah, it's a good resource to have. Okay, the textbook, Conceptual Physical Science by Paul Hewitt and a couple others. This is our lab book. I was shocked last year. This is a lab book where you rip out the pages and turn them in. And yet I had a number of students who had rented the book. And I'm like, how do you rent a book and then tear out the pages and then return it? Does anyone have a rented book? No? Okay. If you have a rented book, let me know and I'll work with you. Because obviously you can't rip out pages and return it.
I don't think they let us rent the lab manuals.
Okay, that would have been wiser. Okay, so those are our books for the class. Class time is, of course, from 10 to 10:50, and then we have lab on Thursday afternoons from 2 to 2:50 p.m. to 2:50. That's not right. 4:50 p.m. That would be a really short lab. So it'll be in this room 2 to 4:50 p.m. on Thursdays, starting this Thursday. So we'll have lab this week. I'm pretty embarrassed. I'll just change it and no one will ever know, right? Especially if I destroy this recording so nobody hears me either. Okay, so the purposes of this class, I have them listed here in an order that I don't remember. The biggest thing that I find is important, or that I defined as important for this class, is to emphasize what the scientific method is. All of science is based on using a certain method of determining what we believe to be true. So science, it is a pursuit of truth with a certain method. And we'll talk about that method in today's lecture. So understanding that scientific method, I guess it's number 2 there, is really important to this class in large part because, once again, I said, 6 of you are education majors. If you go on and you're teaching students, in 3rd grade, you're teaching them science class, it's kind of important to understand, so why do we even believe this stuff I'm trying to teach you? Right? The scientific method is the reason we believe it, and science is not the only way to discern what's true. It's not necessarily the best way, but it's the way that we apply to the physical world. So I want to make sure you understand that, understand how to apply it for yourselves. And to that end, on the first exam and on the final exam, you will have the same question, which I will tell you almost exactly. The question is going to ask you to list the 4 steps of the scientific method in abbreviated form that I'm going to show you in a couple slides. Well, a couple slides once I start the actual lecture. And then it's going to give you, this is the part that I'm not telling you exactly, it will give you an observation. You observe this, and then you're going to have to apply the 4 steps to that observation. And so there's 2 parts. Number 1 is, can you regurgitate what it is? And then number 2 is, can you actually use it? And so that's going to come up on the first exam and on the final exam. And like on the first exam, it'll be worth somewhere around 15% of the exam's grades is just that one question. So it's, it's something I really highly consider important. So I'll underline that or put a box around it because I think it's really important. Other things there to identify the major areas, that is, well, I've already mentioned them and we'll talk about them again, but for you to understand what the areas in physical science are, and for you to be able to take scientific data, to actually be able to make measurements in a way that is somewhat rigorous, right? Not just like random, but in a way that people would look at and say, yeah, you did make sure you ruled out things and that kind of stuff. And how you would draw conclusions from your data, not just say, look, I've got numbers, but be able to draw something useful from it. Be able to solve questions that are both conceptual, obviously the root word there, concept. Conceptual questions are questions that are just seeing if you understand the ideas, and then applications. solving actual problems where you have to do some math. It's because of the application that you have a minimum math requirement for the class, because if you're going to apply equations and solve them, well, you have to be able to do the math. And finally, to understand how scientific knowledge benefits society. Now, I don't sit here every day and say, and that's important because of this, but I think we all recognize, you use a phone. Well, that phone is using enormous amounts of scientific discovery in how it operates. There are many Nobel Prizes associated with what's going on in your phone. So, in everything we do, automobiles, everything using a lot of science applied to make our lives easier. I'm going to skip over these. You can read them at your leisure. One thing I do want to say here is, please don't sit there and text throughout class. It's A, distracting to me, and B, it makes your time in class not well spent. You do spend good money to come here and hopefully get something better than you could just reading a book or watching online. After all the lectures will be available on YouTube. You could not sign up and just watch them on YouTube if that's what you want. But to have the interactivity is, I think, an important part. Accommodations, if you have a learning difference, you always start at the TLC. Just make sure everybody knows that. Academic integrity is, of course, don't cheat. Sad but true. I'm the person that's the chair of the Academic Integrity Committee. So if there's a cheating issue, it goes from me to me. I think everybody understands the importance of integrity, right? If you turn in something that's not your own, what you're saying is, I know something I don't know. And of course, in a class like this, who does it harm? No one. But if you develop a habit of being dishonest like that, and you go out and you're in the real world and you do something like that, well, it has very serious ramifications. And so practicing integrity is important. Like I said, I think you all understand that. What is not as clear to students is what is considered academic dishonesty. So I'm just going to highlight a few of the things that for a class like this, you might not have thought about but that are considered dishonest. So first and foremost, you have homework problems. Oftentimes students get a homework problem and they look at it and they're like, I have no idea. And the first thing they do is ask a friend. They use their lifelines, right? They ask a friend. And is it dishonest to ask a friend? On the face of it, I would say no. I'm the teacher here, so for purposes of our class, no, it's not dishonest to ask a friend. Just like it's not dishonest to come ask the teacher. Is it dishonest for the friend to help you? No, that's not dishonest either. That is just using a resource to help you learn. Help you learn is the key aspect here. Now, what if your friend says, oh yes, here's the solution? That's where we have a problem. Because if the friend explains it to you and you're receiving the information and processing, that's good. But if they just give you the paper, then they have said, here, go ahead and copy, whether that's what you do or not. And if you just copy it, you didn't learn it, right? If you process it, understand it, and regurgitate it in your own thought, then you've learned it. So taking the paper and copying, that would definitely be considered academic dishonesty. But working with somebody, having them explain their answer to you, that's perfectly acceptable. It might seem like they're close together, so I want to make sure that we understand the difference. Oftentimes people go to websites. You've probably heard of Chegg. It's like this major cheating website. People go there and cheat all the time. Does it help them? Well, it helps them get better grades, but it also makes them not learn the materials well, which means test time, they probably do worse, right? If you have access to a solution manual, that's considered cheating. I've had multiple cases just this school year of people who had access to solution manuals through, and one of them was through Chegg, and teachers were like, Chegg? I never heard of Chegg. And that's definitely considered dishonesty. So giving your paper to somebody, taking somebody's paper and copying, those are both considered cheating. Those are the ones that students are the most confused about. Another thing that seems simple but it's not, Some classes like pass around a paper you sign up, and somebody's like, well, John's not here, but he's going to lose credit if he's not here. So I'm just going to sign him in. That's very blatant dishonesty. I won't be doing that in this class, but a similar thing that you could do is we will have, starting next lecture, not starting today, clicker questions where I will pause the lecture. There'll be a question up there asking you what you think. The reason I use the clickers is because then nobody has to feel self-conscious. I don't know I can go look it up, but I don't. I don't know what you've answered. Nobody else knows what you've answered, but you are forced to say, well, this is what I think. And you get credit just for trying to answer, not if you're right or wrong. And so I always had up here that it's dishonest to click somebody else's. A couple years ago, I had a student who did just that. His friend had gone to the bathroom, and so he just reached over and, clicked an answer for him so his friend wouldn't lose the point for not participating. That actually kept the person out of medical school in the end. These are things to just understand. Your grade will be broken up by a number of things here. The clicker participation. When we have a clicker question, it's a question to either test what you knew coming in or if you understand what we've been talking about. If everybody gets the right answer, I'll just say yay and move on. If we have something less than that, I might have you discuss it with each other and re-poll the question, ask the question again, assuming the new software is working right again. Or I may explain it, or I may, and this is what will happen most of the times, whether you discussed it or not, when we're all done, I will draw a card that has your names randomly on them. So I've got oodles of business cards from when I arrived here 15 years ago that I never used. And I'll call your name and say, explain how you got, what your answer was and what you got. And I will give a qualitative score based on your explanation. And so you will get a portion of your grade will be that qualitative score, and the other portion will be just what percentage of the questions did you answer, whether you were right or wrong. Okay, so that's 5% of the grade. Potential test questions. We won't be doing it today, but for every lecture subsequent to today, if I'm talking about new material, I'll be giving you one of these sheets. Well, next class, actually, here, let me just hand out what I have now, and then I'll have a lot more for next class period. So, don't take just one, take a few, whatever. So if they're all gone when you're done, but make sure Samuel gets shut out the cold. So you will write a question that you think would be a good multiple choice question for a test. Not too hard, because we want our test questions to be ones that people can answer. Not too easy, because we want to have some discrimination in the questions. We don't want it to be, well, everybody got that point. And it needs to be relevant to what I talked about. It needs to not be copying a question from the textbook. And so I will go through, and after each lecture, I will grade those for their topic, if they're on the topic I talked about that day in class, and the quality, if it's not too hard, not too easy, and the originality. The originality scores are going to be good for you guys, because with only 7 or 8 students, what I do for the originality is if 2 students have the same question, it goes down 1. Well, your odds of having 2 students with the same question are smaller with a small class. So those are the things that I use to grade that, and together those again are 5% of your grade. So for every lecture, not counting today, if I'm lecturing, if it's not a review lecture, or if it's not an exam, of course, then you'll be submitting one. Those questions will go to 2 things. All of the quizzes will be 100% potential test questions. So every quiz will be questions that you guys wrote. None of the quiz questions will be ones that I wrote or the textbook. The exams will be a 50% questions that you guys wrote, 50% questions that come from the textbook authors. So those questions are going to be important to you. Now, actually, I put these percentages down. With this few students, it might be hard to reach those percentages. I might end up using all your questions, but that's at least the goal. Homework, there was a homework assignment due every week, except I don't think there's one this week. Don't think. We can always, no, we can't check on this. You have an easier way to navigate than I do right about now. Here's the course schedule. And yes, there's no homework due this week. But generally, there's a homework assignment due every week. There are a few cases where there is not, because like we had a test, vacation or something. There's only like one lecture that would have been covered by the homework assignment. And I'm not going to give you assignment just for one lecture. So they're basically every week. They are due, I believe it's Wednesdays. And you can either turn them in on paper by 5 p.m. at my office, or you can turn them in online on Moodle as a PDF file up until 11:55 p.m. So you have more time if you turn it in online. I prefer it if you turn it in online, but I don't force people because some people just aren't comfortable with that. There are photocopy machines around, like one down the hall, one upstairs. If you have it on, which you probably will have for the most part, on paper, you can just go to the photocopy machine. There's a little card beside it that you put on it that allows you to scan and email it to yourself. And then from that email, you can just upload to the homework. Laboratories, we have one of those every week. Those are 25% of your grade. They're 1/4 of the class. Those laboratory experiments are where you actually get to see if what I'm telling you in class is true. So, those are important. Come, do them. You have to finish the lab before you leave. They shouldn't take you more than 2 hours. It's a 3-hour period. So you should be able to leave early. Sometimes you'll stay for the whole time. And when you leave, you have it all done. You don't have to worry about anything until the next week. Final exam is cumulative, right? My goal is that you leave this class knowing something, not just, it went in one ear and after the test it went out. And so that's why the final exam is cumulative. I hope that when you guys go on to teach, everyone except Samuel, that you will adopt a similar approach, that you actually expect your students to know more at the end of class than they knew at the beginning and not just have gone through hurdles in between. Now there's a couple special areas. Lecture assistance. Now you can only do this once. That is, you can only get credit for it once. In most lectures, I will have demonstrations. This is a demonstration for my lecture in the next class. I'll bring it back for you guys halfway through the semester. We'll have demonstrations, and I invite students to, before class, make arrangements, come and talk to me. We'll talk about, okay, you're going to do this demonstration. These are the things you're going to do. You're going to explain it to the class. So the student is actually doing a little bit of the work up here with the demonstration and showing them how it works and explain how it works. And for that, you can get up to 1% of extra credit. I say up to 1% because if you do a really, halfway job or whatever, then you don't get the full amount, but usually people get the full amount. And so that's a big chunk of extra credit. The only other thing I haven't talked about that's important here is the attendance bonus. I personally have a philosophical difference with effort points. Richard tried so hard. Shouldn't he at least get a B in the class just for trying? I view classes as, did you learn it or did you not? But this is where I give a little effort points. If you have, quote, perfect attendance, perfect defined as if you're allowed one absence per semester for school activities per day that you have class a week. So we have class 3 days a week, hence you're allowed 3 excused absences by that policy that appeared and disappeared in the handbook. Seems like every time I adopt something, it disappears. And so I've taken that and I say, if you have 3 absences or less, that counts as perfect attendance. That's, if you've missed less than a week. And I have a point method of determining how much a tardy is worth. So if you're here before class starts, you get 3 points. If you're not here before class starts, but you arrive within the first 5 minutes of class, you get 2 points. If you arrive more than 5 minutes late, or if you're sitting there on your cell phone all through class, or if you, and I've had students do this, if you get up in class and you go and you buy some food at the snack bar, and you come back a half hour later after you finish your meal, then you get 1 point. And if you're absent, you get 0. And then there's a question, what if you're excused? Well, that's why you have the 3 that you can miss. So excused is still 0 points, but you can lose 9 points. The key here is I don't ever ask you if it's excused or reasonable or not. I just assume the first three, you had a really good reason for it. And after that, well, that's going to start taken away. So all of that to say, if you have the perfect attendance, then I give a 2.2% overall boost to your grade. So like if you were at 88.5%, which is a low, but a low to middle B plus, it would raise you to 90.5%, which would be a nice A minus. So that's the one additional thing. Here's how the grades break down. I do round, so if it says 93%, 92.5% rounds up to 93. There are some teachers who are very adamant, no, 93 is 93. Did you reach it or not? It's just a different point of view. Okay, any questions about the syllabus? Okay, then I am going to go to the schedule just to make sure we understand how to read this schedule. So here is the schedule for the class. So today is, in theory, coming from the prologue of the textbook. We'll get there in 5 minutes or so. It's an introduction to the class. Before you come to class, it would be best if you had read the prologue. Well, of course, you didn't know that's what I was going to do. I didn't expect you to read the prologue before coming to class. But this reading here is what I'm planning on covering in class. So if you read it beforehand, then you're kind of primed. You have an idea of what I'm going to talk about and what you understand. And something, if there's anything in there that just didn't make sense to you, wow, that didn't make sense. I've got to ask a question about that. So that's what the reading is for. So it'll be chapter 1, sections 1 through 7, talking about force and inertia on Wednesday. On Thursday, we don't have a lecture on Thursday, but we'll be doing the lab Sonic Ranger, which is page 11 of this. So you know beforehand which one you're going to be doing. You can read it and be ready when you come to lab. And then our first homework assignment is due on Wednesday. It just says here HW01. I haven't actually put it yet in Moodle, but the actual assignment will be uploaded in Moodle so you can copy it, put it in your word processor, whatever you want to help you in doing your solutions. And you can see all the important things. When the exams are, it's in red here. Of course, the copy I gave you is not color copy, so you can't see it in red. And, final exam, the whole 9 yards. So that's the schedule for the class. Any questions about the schedule? All right. Then it is time to actually start talking about class-like things. I start with the PowerPoint slides that come with the textbook, and then I modify as I see fit. And so you see that there is a certain style here. These are the topics in chapter 1, actually. We're not going to talk about chapter 1 unless we finish the introductory material. So defining science. Science is defined by the scientific method, and this is the method shown in the textbook. It's not exactly what I'm going to test on. The slide after this is what I'm going to test on. I put this here just so you can have the reference for what's in the textbook and understand the variations. Probably if you ask every scientist what the scientific method is, you're going to get a slight variation on it. But the key to the scientific method is it starts with you observing something interesting. So in both the one I'm going to show you in a second and this one, observation is the first step. You have to be curious if you're in science. Scientists have to wonder why something. Go back to when I was a child. My parents, as part of bribing me to let them kill my dog, take whatever. My dog apparently was in nuisance, I didn't know. They bought me a little toy car set. And after I'd had the toy car set about 2 hours, I took apart my best car to see how it worked. And my dad shaking his head, there's something not right with that kid. And that's when he was pretty sure he's probably going to be a scientist of some sort, because he's not just happy to have the cars go zzz around the track. He wants to know how they work. And I'll tell you, I took it apart and I found they had these magnets, which was cool because I love to play with magnets. And so I took out the magnets and played with them, and I said, these are just a weight. Why would they put weights in the car? They'll go faster without them. So I put the cars back together without the magnets. Wah, wah. Electric motors require magnets. And so that was where I learned that. And then, of course, I put them in wrong, and I learned a lot of things about physics there by taking apart the cars. I didn't intend to learn everything I did. The second step is, this one here says question. I say hypothesize on mine. The second step in the scientific method is to come up with an idea of why you think the thing you observed happened. So that question, make an educated guess. An educated guess is a synonym for a hypothesis. Hypothesis is an educated guess. You have some scientific understanding, and you are saying, well, based on the scientific understanding, I think this might have occurred because of this. So you have to have a connection that says, because of this, this happened. And that hypothesis needs to make predictions. It needs to predict what would happen in a different situation. Not just what happens in the situation you observe, because you know what? You already observed that situation. It needs to make a prediction into a new situation that you could test to see if it's making correct predictions. If you have a hypothesis that doesn't make testable predictions, then it's not a scientific hypothesis. That scientific hypothesis also needs to be based on scientific ideas. Now, this brings up something that everybody's at least a little familiar with, your horoscope. Now, what is the underlying theory of astrology?
When you were born affects your life.
Okay, when you were born affects your life. More precisely, astrology says that where the sun and moon and stars and planets were when you were born, and where the sun and moon and stars and planets are now, are scientific data. Is that scientific data? Are you measuring actual objects or actual values? Yeah, that is scientific data. That relationship then is going to affect your life and make predictions about your life. And so if you look at a horoscope, it's telling you predictions of your life based on the positions of the stars. So it's based on scientific ideas, based on scientific knowledge, measurements. And it makes predictions that are somewhat testable. Obviously, they make them very broad. So, something good's going to happen today. Yes, I had something heavy fall on my toe and it smashed it, but it didn't separate, so good. You can always find something good. But it makes predictions that are testable. So is it scientific? I see some variation of opinions. Right, this would be a good place to have clicker questions, but I'm not doing it today because people didn't have time to set them up. Clickers, by the way, I mentioned we're using them. I didn't mention anything else about them. If you have a cell phone, then you can just use your cell phone as your clicker. You don't have to go buy a physical clicker. If you have a physical clicker, you can use it. In both cases, you have to register your clicker account through Moodle for it to actually give me the scores. Before you have it physically registered, I think you're still allowed to answer, and it will record them, so when you're registered, I get the scores, but I won't get the scores until they're registered. So if you've already done it, hooray. If not, come talk to me or whatever, we'll try to figure out how to do it. It's not like I'm a pro with it either. But hopefully you'll have it by next class period, so we can start doing polling. The 100% unanimous among scientists consensus on that question is that astrology is not scientific. It's what we call pseudoscience. It starts with scientific measurements and observations, and it makes testable predictions. But you actually can't draw any causal relationship between the observation and the prediction. There is nothing you can say, oh, because of this action of the moon, you have this result in your life. You can make statements like that, but you can't show a cause and effect relationship. And so thus we deem it pseudoscience. Science has to have that cause and effect relationship that is based on scientific ideas and not just, well, we've got scientific measurements and we make a prediction. The next step is testing it. Test your prediction to see if it is what actually happens. And if your prediction is what happens, you did not prove your hypothesis correct. My wife still argues with me on this. She thinks that it's a waste of time if we can't prove things correct. What science can do is it can prove things incorrect. If the prediction is not what happens, you've just shown that you were wrong. But if your prediction is what happened, it could have happened because of your idea. It could have happened because of a different idea. So you're not done after you do that first experiment. You go back and if it does what you predicted, you say, okay, what's another prediction or another way I can test my hypothesis? And you do it again, and again, and again, and again, and again, and again, and again. The scientific process never ends. I think it was Einstein who said, there's no experiment in the world that can prove me right. But it takes only one experiment to prove me wrong. Now, there are some hypotheses that we have tested a lot. And after we get a lot of confidence in these hypotheses, we drop the name hypo, or the prefix hypo, and we just call them theories. And you can go from a theory to a law. There's lots of little subdivisions here, like a law is something that's broadly applicable and has the equations, one definition of a law. Theories might be more directed. It gets confusing to me on how we slice and dice the difference between a theory, a law, a principle. The difference between a hypothesis and a theory is a theory has been generally well tested, whereas a hypothesis has not been. And so we have things like the theory of gravity that says if I take this battery and I let go, that there is a force that's going to make it fall. And that theory has been tested so many times, no physicist thinks that it's untrue. But it's still never been proven. Because you can't prove things correct. Yes, I see squinting, much like my wife. Who you all know, right? Except for maybe Sandra. Yes. Wonderful woman. So this last step, draw a conclusion, this is not the end of anything. That's the reason I don't use this one as the one you're being tested on. People tend to think, oh, it's over. We've done a test, now we draw a conclusion. No, you do lots and lots of tests, and you start publishing what you think is happening, but you never are done. It's not over. And so that's why I go, instead of with that one, with this list here. So this is the one that you need to have memorized. You're going to have to regurgitate on the first and the last exams, and you are going to have to apply on the first and last exams. So the first step, observe something interesting. And once again, I see people take pictures, which is absolutely fine. Believe it or not, I have colleagues who don't think it's fine. It's my private material. How dare you have a copy of it? I do provide this also on the OneNote. So if you go to OneNote, you'll see my lecture stuff. You can view it there as well. So you observe something interesting, have that curious mind, then you create a hypothesis that has to do three things. Explain why the observation occurred, be based on scientific ideas, and make testable predictions. Has to do those three things. So you're going to have to, on the exam, for number 2, you're going to have, bullet point 1. Well, you start with create hypothesis, then bullet point 1, bullet point 2, and bullet point 3. And then the next step is you test a prediction. Really, really important. You're testing a prediction. You're not going back and repeating your observation. You've already made your observation. If your observation is what you have for your application on the test, that's not going to get you the point. Your test needs to be testing a prediction that's not what you observed, something new that you didn't know was necessarily going to happen. And then, based on the outcome, if the hypothesis passes the test, you go back and you test your prediction differently, or you test a different prediction. So you go back, do more tests. If your hypothesis fails, remember, Einstein, only one test to prove me wrong. If your hypothesis fails the test, then you go up and you have more information. It's not a failure in life because now you know, okay, it's not that. Since it's not that, then maybe it's this other idea I also was thinking about. And so the scientific method is a method of constant corrections when you find that you're wrong. So we take something like, okay, I do not personally believe that life evolved. I believe that God created life pretty much like it is today. There's been variation, but no new species, lots of species of God. Okay, that's my belief. But we have evolutionary theory. And evolutionary theory is constantly changing. You'll see creationists like me who point to it and say, well, look, you just changed it. If it wasn't right then, what makes us think it's going to be right now? It's a pretty valid statement, but that is the way science works. Science, we're constantly updating our beliefs, updating our knowledge as we do more experiments. And so that's the way it's supposed to be with the scientific theory. So it's not really it's a valid statement, but it's not really an argument against evolution. Because that's the way science is. That's the way we understand things. And so that argument is basically saying, I don't really understand science. So when is the scientific method done? It's never done. Which, when you go to graduate school and you're working on getting a degree and you realize this is never going to be done, it can be depressing. What happens? Well, you start working on a project and you learn something and then you test differently and test differently. Finally, somewhere down the line, you get to the point where you have learned something that no one ever knew before, which technically, at least what I was taught, is what it takes to get a PhD. You have discovered knowledge that nobody else knew. But your problem's not done. And so, research that I did when I was working on my master's degree, a decade later, we wrote another paper on that same project because we're able to, with new technology, make a test in a different way and see better what was happening. It's never ending. And so it just keeps going on and on. Graduate student after graduate student will just pick up the project and move it forward. Next one picks it up and moves it forward. Let's do a practical application, because after all, you're going to have on the test, I told you I'm going to give you an observation. This is my favorite observation. You observe ice cream tastes better at Cold Stone Creamery than, that's an A, than at the dairy. Growing up, yes, I grew up in Monterey Bay Academy. I worked at the dairy. I tend to think that ice cream wouldn't taste very good working there. That's my observation. Now we have to apply the 4 steps. So what was step number 1? Observe something interesting. So what do I do for my application? Basically rewrite that, write it in shorter words. You don't have to write all the words, but that's what step 1 is going to be. It's just going to be, this is the observation because I gave you step 1. I don't tell you this is step 1 because I want to make sure that your brain has that connection. This is the observation. So step 2, what's step 2? Create a hypothesis. So I'm just going to go to 2 here. Create a hypothesis that does 3 things. First thing is, explains why it occurs. So I have to say, why does ice cream taste better at Cold Stone Creamery than it does at the dairy? Needs to be based on scientific ideas. I need to have some kind of science to back this up. And it needs to make testable predictions. So let's just throw it out there. In the end, we're going to go with my hypothesis. But I want to hear yours. Why do you think that ice cream might taste better if you are at Cold Stone Creamery than if you are at a dairy with the cattle and the cattle waste products.
Well, it smells better at Cold Stone.
Okay, smells better at Cold Stone.
It smells like ice cream and the cones that are.
Any other ideas?
It's in a better environment.
Okay, better environment.
It's been tested by a lot of different people, or eaten, I guess, by a lot of different people, whereas the dairy might not.
Okay, I don't follow that one as well, but right, there's no right or wrong with your hypothesis because it is what you think. Now, it has to be based on scientific ideas. I am going to focus in on,
It's complicated. You can call me Danny.
all right,
I'll respond.
I'm going to focus in on Danny here because hers was my answer. It was the first one, but I didn't want to just cut things short and everyone else not have a chance to think. Because it smells better. Now, we need to have a scientific reason, scientific backing. And we have good scientific research that says that smell is part of what we interpret as the taste of something. So if you have nasty medicine, and if you know my wife, you know that she believes in health products, and sometimes she makes me take really nasty smelling health products. First thing I do when I'm going to take that is have an arm's length plug my nose and bring it up and drink it because I know it's not going to taste as foul because the smell is contributing to the taste. So there's a lot of research on that. There's a scientific connection. We know that smell and taste are interrelated. So because smell and taste are interrelated, and it smells better at the Cold Stone Creamery, my hypothesis is it tastes better there. Cold Stone, Stone Cold Dairy. I'm not sure. One's Steve Austin, one's Ashton. So we have taste affects smell. That's a CTS, not a SCT. It's also smell affects taste. I'm not dyslexic, I don't think, but that would be multiple forms of dyslexia right there. What I am is I write faster than I think. Or I think faster than I write, I mean. Smell affects taste. Cold Stone Creamery smells good. Therefore, tastes good. Okay, there is a good, valid hypothesis. Now, the next step is I need to test a prediction. So my hypothesis is essentially the ice cream tastes better because of a good smell. How can I test this? Check to make sure time's not up.
Eat ice cream somewhere where it smells bad, and then eat ice cream somewhere where it smells good.
Okay, that's the seed of how we're going to do it. Eat it somewhere where it smells bad versus somewhere where it smells good. But if you just do it yourself, that's kind of a limited test, right? So when I was in graduate school, I did every psychology test that they advertised in the Daily Evergreen. Go watch the state. So I did studies where we got to go to the cafeteria to eat whatever we wanted, and then we had to record how many calories it was in multiple ways and see which way was more effective. Got free food. Did one that tests the cancer-killing aspects of cheese. Don't tell Amy, that would make her angry. Did a couple of them on being in isolation and how that affects different things. Totally cool. And they give you money, give me pizza, all kinds of stuff. So we want to do a test where we can have lots of things. So here is my test. I think it's so well designed. We want to test smell versus taste. So we get ourselves a nice laboratory room like this, and we put in here a bunch of little covered heaters. And in those heaters, we put apple pies. So it's going to taste or smell really good in here. And then we invite our test subjects in and we give them some ice cream. And we have them rate that ice cream. How good did it taste? And then we pay them all $5 or whatever and send them away and say thank you. And then we take out the apple pies and we put in cow pies. And so the whole room smelled like bovines. We bring in another group of test subjects and we feed them the same ice cream. And we ask them to rate how good it tastes. And pay them $5 and say thank you. So now we've collected data. We had a bunch of people. We controlled the environment. It was the same ice cream. It was the same surroundings, right? Because she said surroundings. We want to make sure we rule out other things that it could have been. Right? Or environment. So we want to make sure it was the same environment, and it was only the smell we were testing. Right? We didn't repeat the experiment. We didn't just go to the dairy versus go to Cold Stone Creamery. We cut down the variables and just did a test. And what outcome would confirm my prediction?
The last one with no smell.
The what?
The last one with no smell, if it was different with the rest of it.
Okay, which way different?
If there was any difference at all between the one that had the good smell and bad smell or the one that didn't have any smell.
Well, my prediction was the good smell in Cold Stone made the perception of taste better. So to agree, it's going to have to be the apple pie scores were higher. If the apple pie scores are the same or lower, then I disproved my hypothesis. So if the apple scores are higher, apple pie scores are higher, then what do I do with the scientific process? It agreed, so you go back to number 3. You test a different prediction. Because it confirmed, I'm just going to test differently. So now I'm going to do something different. I might say, well, that was with ice cream. Let's see what happens if we change it to bread. Or you might say, okay, that was the smell of apple pies versus cow pies. Let's change the smells up. More tests to see how consistent it is. What if it was wrong? What if the people thought it tasted better when you had cow pies brewing?
That's when you have to adjust your hypothesis.
Yeah, you have to adjust the hypothesis because you were wrong. So now you go to her and say, maybe it was the environment. Let's do it in a cold and sterile room versus at the fair. Not at the fair because that's too uncontrolled, but, and change the environment. So on the test, you don't have to say what the new hypothesis is going to be or what the new test is going to be. You just have to say, if we have this result, so you have to be specific, like I said, in this case, if the scores for taste are higher with the apple pies, then I will go back and adjust my test to test a different prediction or test it differently. If the scores are not higher with apple pies, then I need to go back and adjust the hypothesis to something new. Okay, I am out of time now. So